Polymers can be classified into two classes, i.e. plastics and elastomers. Plastics are moldable organic resins. These are either natural or synthetic, and are processed by forming or molding into shapes. Plastics are important engineering materials for many reasons. They have a wide range of properties, some of which are unattainable from any other materials, and in most cases they are relatively low in cost. Following is the brief list of properties of plastics. Lightweight, wide range of colors, low thermal and electrical conductivity, less brittle, good toughness, good resistance to acids, bases and moisture, high dielectric strength, use in electrical insulation, etc. Plastics are again classified in two groups depending on their mechanical and thermal behavior as thermoplasts, thermoplastic polymers, and thermosets, thermosetting polymers. Thermoplasts. These plastics soften when heated and harden when cooled, processes that are totally reversible and may be repeated. These materials are normally fabricated by the simultaneous application of heat and pressure. They are linear polymers without any cross-linking in structure where long molecular chains are bonded to each other by secondary bonds and/or intertwined. Common thermoplasts are acrylics, PVC, nylons, polypropylene, polystyrene, polymethyl methacrylate, plastic lenses or perspex, etc. Thermosets. These plastics require heat and pressure to mold them into shape. They are formed into a permanent shape and cured or set by chemical reactions such as extensive cross-linking. They cannot be remelted or reformed into another shape but decompose upon being heated to too high a temperature. Thus thermosets cannot be recycled, whereas thermoplasts can be recycled. The term thermoset implies that heat is required to permanently set the plastic. Most thermosets composed of long chains that are strongly cross-linked, and/or covalently bonded, to one another to form 3D network structures to form a rigid solid. Thermosets are generally stronger, but more brittle than thermoplasts. Advantages of thermosets for engineering design applications include one or more of the following: high thermal stability, high dimensional stability, high rigidity, lightweight, high electrical and thermal insulating properties and resistance to creep and deformation under load. Epoxies, vulcanized rubbers, bakelite, unsaturated polyester resins, and amino resins, ureas and melamines, are examples of thermosets. Elastomers, also known as rubbers, these are polymers which can undergo large elongations under load, at room temperature, and return to their original shape when the load is released. There are a number of man-made elastomers in addition to natural rubber. These consist of coil-like polymer chains. Those can reversibly stretch by applying a force.